Okay, so our first unit of this year is going to be about maps because if we're going to describe the Earth and talk about all things in the Earth, we got to be able to talk about where they are. So here's what you need to do while you watch this presentation. You just got to watch it and learn something. Take some mental notes of key vocabularies, ideas, concepts, stuff that you see come up. Do not write anything down. I don't want you to take notes. At the end, there'll be a little summary document for you to complete that will prove to me that you learned something. You don't have to learn everything, but you got to learn something from this. So pay close attention and listen carefully. So we are going to be studying all things Earth, whether it's a weather event or a geologic event like an earthquake or a physical feature like where a volcano is. Well, we need to describe where those places are in order to talk about them. And the problem with describing location is most of the time that when we describe where something is, we talk about political boundaries. We say it's in this country or it's in this country or in that country. And even more specific than that, we say it's in this country, and then it might be in the state of Georgia, then it might be in the city of Roswell. Well, physical things, earth things, they don't know political boundaries. And we need to be very exact about where we describe things are located. So we need some kind of system. And we're going to use a system that is very similar to what you've done in math. We're going to use a coordinate system. This X and Y you're very familiar with, and you know that if you go over 3 and you go up 4, you are right there. You also know that if you go over 5 and down 3, you wind up right there. Two distinctly different places, and we know exactly where you're talking about if we say 3 negative 5 versus, 5 negative 3 versus 3 4. Two distinctly different places, and that is its own set of points, that is its own set of points, and that is its own set of points. Well, we're going to take this same system and we're going to apply it to the Earth. The question becomes, where do we draw the lines? And how do we draw the lines to make my X's and Y's? The Earth, you could think of as a sphere. Think of it as like this orange. It has a top half, a North Pole, and has a south half, South Pole. So we want to cut this up and we want to put an X and a Y somewhere where we say we go this X and this amount of Y. We know exactly where we're talking about. But where do we draw the lines? The problem with a sphere is you got to be careful about where you cut the lines. If I cut the line up here, well, then I wind up with a lot more south than I wind up with north. If I cut the line here, I wind up with more south, or less south and more north. There's only one way that you can cut a sphere and wind up with 2 equal halves, and that's if you cut it right down the center. And that's what you have to do with your x-axis, is that you have to cut it right around the middle. There's only one place to do it in order to make it equal. So here's what that cut line would look like. It goes right down the middle. You notice you have the same amount of north as you do south. This line that is right around the middle of the Earth that cuts it into a northern part and a southern part is called the equator. The equator is the line drawn around the middle of the Earth that separates it into a northern half and a southern half. Well, those halves of the planet have a name. When you cut the Earth into 2 equal halves, they are called hemispheres. So this is the southern hemisphere, and this would be the northern hemisphere. A half of the Earth is called a hemisphere. Now, it's not enough just to say something's in the north or it's in the south. We need to be a little bit more exact than that. But once we have 2 separate halves, now we can start dividing them into smaller sections, very similar to what you do with numbers on a ruler. You make a line for 4, and then you make a line for 5, and then you make a line for 6 with a 1-foot ruler. Well, we can do the same with our planet. Once we have our starting point, we can now cut the hemisphere into smaller and smaller sections. I can make another line. I can make line number 1. Then I could make line number 2. And I can keep going over and over again until finally I've got a series of numbers that I can use to measure. Okay, I started off at this 0 line, the equator, and I went up to line number 1, line number 2, or I'm at line number 3. And I can keep making more and more lines until I describe how far from the equator I am, either going up or going down. These lines are called lines of latitude. The lines of latitude measure how far north or how far south you are from the equator, which is that line in the middle from which we all start measuring. So you're 1, 2, 3, 4, 5, 6, or 7, or 8, or 9 lines of latitude south from the equator. Or you're 1, 2, 3, 4, 5, 6, 7, whatever number of lines you are north from the equator. And just like a ruler that can be divided into smaller and smaller pieces, you can get more and more and more lines of latitude. Lines of latitude are described using degrees. Because when you cut a sphere and you start off here in the middle, you know where to cut a line based on an angle, and the highest angle you can get is 90 degrees. So that would be the line that has an angle of, say, 10 degrees. And here I would draw the line that is an angle of maybe 45 degrees. So lines of latitude are described as being some degrees north or south from the equator. So you'll have a set of lines of latitude that will measure how far you are going north or how far you're going south. Now notice the pattern here. These lines go around the earth and they never intersect with one another. For that reason, lines of latitude are also called parallels, because they never intersect with one another, because they keep going around the earth like this, like this, like this, like this, and they'll just come around the earth and they'll never touch one of the other lines. Hence, lines of latitude are also called parallels. So now we've got to start. We know that the equator is the 0 latitude, and I can measure any place north or south relative to the equator. I start at 0 and I would count 1, 2, 3, 4, however many number of lines of latitude. I go north or I go south, and that tells me my north and south location. The problem now becomes we still need to describe how far are we this way or this way. So we got to draw another line. We've got to draw some kind of line this direction so that we split the earth into 2 halves, and that's where the problem comes in. The problem with the lines going this way is, where do you cut? I've got more than one choice. With the equator, I could only make one cut right down the middle. If I cut over here, I didn't wind up with equal halves. If I cut over here, I didn't wind up with equal halves. The problem with cutting this way is I could cut like this and wind up with a half and equal half. If I cut like this, I still wind up with an equal half and an equal half. So the question becomes, where do I cut? Where do I start to make my line so that I can count I'm in this half or I'm in the other half? So we've got all these choices on the earth. I could make a cut right there and divide the earth in half. I could make a line right there and cut the earth in half. As it turns out, there's a line that runs right about here that we use to cut the earth into 2 separate halves. These are also called hemispheres. But now this is the east hemisphere and this is the west hemisphere, as opposed to a north and south half. Now we have an east and a west half. This line, this 0 line, goes through the country of England. Now, this line could have been drawn anywhere. We could have split the earth in half. If this is England right here, we could have cut the earth in half through England, or we could have cut the earth in half through the USA, or we could have cut the earth in half starting in China. So why does the line to cut the earth in half start through England? Well, it goes back to the 1800s when England was the most powerful country on the planet, and they had an empire. They had Canada, they had colonies in South America, in Africa, Australia, in the Far East, and they had to send ships all over the world to the different ports of their empire. So they needed really good standardized maps. So the English sat down and said, you know what? In order to describe exactly where my ships are going, whether it's Australia or Hong Kong or India or the Americas, we need a system. So at the time, they were the most powerful country in the world, so they basically got to set up the system, and they set up the system so that the zero line ran right through their country because that was the starting point. That's where their ships were going. Had this system been developed in the 20th century, odds are the United States would have been the zero line because at that time, the United States was the most powerful country in the world. But we've got our zero line in England, and everybody else measures from this zero line. The lines going this way are called lines of longitude. And lines of longitude measure how far you are either going east or you're going west from this zero line of longitude. The zero line of longitude also has a special name. It is called the prime meridian. A meridian is another name for a line of longitude. And just like with the lines of latitude, we're going to have multiple of them. There's longitude line 1, 2, longitude line 3, and so forth and so on. So you count from 0 and you go over 10 degrees west or 20 degrees west or 30 degrees west or 40 degrees west. And you do the same thing going the other direction. And by doing this, you get a system of X's and Y's. You get a point where you know exactly where you're at. So here's my X and Y grid system put onto a world map. This is 0 longitude, and that is 0 latitude. Equator, and this is the prime meridian. These are my X's and my Y's. So now I can count. If I have more lines drawn on this map, I can say I'm going 1, 2, 3, 4. Let's say 40 degrees going east, because this direction is the eastern hemisphere. Going that direction is the western hemisphere. How much do I go north and south? North, south. I go 10, 20, 30, 40 degrees north, and I go 10 degrees east. I wind up right there. Now, when we describe latitude and longitude, the latitude line is always described first. So for this particular point, I would say this is 1, 2, 3. I would say this is 40 north, and let's say this is 10 east. Why do we list the north first? Who knows? Just like with your X's and your Y's, you had to pick one that you always say the X's first or the Y's first. The same is true with latitude and longitude. For latitude and longitude, you always say the latitude first and the longitude second. So for a point that's right here, I would say I'm 1, 2, 3, 4. Let's say I'm 50 south, because I am south of the equator, and then I am 10, 20, 30, 40, 50, 60. Let's say I'm 70
Sorry for that pause here, but we'll have a little quick summary. First of all, red bold-faced words. These are key vocabulary, and I'll usually do something like this, especially here early in the semester, to kind of just call your attention to the stuff that you should have gotten out of that presentation. Once again, latitude, longitude, measured in degrees, talking about the equator, 0 degree latitude, get north and south hemispheres. Now, the prime meridian is at 0 longitude and goes through Greenwich, England, separates the Earth into east and west hemispheres. You can actually go there. It's actually a kind of a tourist attraction, and you can see my picture over there. I'm standing on the prime meridian with half of me on one side and half of me on the other. That means I am in both the eastern and the western hemisphere at the same time. But one thing about the east and the west hemispheres, if you go west, you will wind up east. And if we think about something like going this direction, if you go far enough this way, you're going to wind up over here. Well, you'll start off in the eastern hemisphere and you come around to the western hemisphere. And this concept, this idea, kind of lends itself to some of the names of particular islands on our planet. If you remember the story of Christopher Columbus, he was going this way. He thought he could go to the west and make it to the area that they called the Indies, the area around Indies and South Pacific. And he was right. However, he didn't count on bumping into North America, and he bumped into these islands here. And they looked a lot like the islands he was trying to get to, but he very quickly realized, hey, it's not the same place. They're similar. Well, these islands over here then got the name the West Indies. They were the Indies that you got to by going west, versus to what then came to be known as the East Indies, or the islands like the Indies that you got to by going east. So now here's some fun trivia about latitude and longitude. In what state is the easternmost point of the United States? And you're looking at this map, it looks like this guy over here, sticking the most this way. It is the easternmost point. Even though it's all in the western hemisphere, it is the point that is eastern the most. This is the lowest latitude in the western, or longitude in the western hemisphere. And that's the state of Maine. You'd be right. Now, what is the westernmost point? Now, the continental United States, you look at this map, we know Alaska is kind of sticking way out there. So, yeah, we get it. Alaska would be the westernmost point in the United States. However, if we look at Alaska a little more carefully, this line right here is the 180-degree line. It's the opposite. It's that international date line on the other side of the prime meridian. So all of this here is the western hemisphere. We've gone this way. We've gone west from the prime meridian. Well, over here, we're in the eastern hemisphere. And what's true about Alaska is that there is some of Alaska that is actually in the eastern hemisphere. So a little bit of funky trivia about latitude and longitude is that Alaska is technically the westernmost state in our country, and it is actually the easternmost state in our country. Now, let's talk about applications of this mapping. Like, why should we care about this stuff? Well, because we use maps a lot more than you think we do. First of all, we all use GPS, some kind of Google Maps or Apple Maps in our phones. And what you may not realize is that your phones don't tell you where you are with a typical road map. What your phone is doing is getting your GPS location, and it's just overlaying that over the coordinates on the map, the drawn map. So our phones don't read a road map. So how do they know where they are? Well, they use GPS coordinates, which is so much better because you think about street names. In Atlanta alone, there's 15 different roads that have the word Peachtree in them. It's real easy to get confused. If you look at our location here we are at Innovation. We are at 126 Milton Avenue. Now, there could be another Milton Avenue somewhere. You could get the number wrong, be like, instead of 126, maybe you said 226. Think about trying to find your way to Innovation Academy. It can be kind of confusing. However, this is how Google Maps will show you where Innovation Academy is. You might not have ever paid any attention to these numbers down here at the bottom, but those are the latitude and longitude coordinates of Innovation Academy. And you can see they're out to a lot of decimal places because you can get very exact with latitude and longitude. Let's consider our campus. You can be in two different places on the campus, and yet your address would still be 126 Milton Avenue. If you're over here in the engineering wing, that's your latitude and longitude. Maybe you're over here in the fitness center, that would be your latitude and longitude. And you see they're pretty similar to one another, but out here at the end, there are some slightly different numbers. So latitude and longitude can get very, very exact, whereas everything in this picture would be classified as 126 Milton Avenue. Another advantage of latitude and longitude. What about places that don't have street addresses? Here I'm on a hiking trail way up in the mountains. There's no street address there. But if you needed to find somebody there, say the ranger needs to go on a rescue operation, a hiker fell and broke their leg, and you want to know exactly where they are, you can't tell them, oh, we're somewhere at 126 Milton Avenue. You give them that latitude and longitude, and that'll tell you the exact location. If you're on a boat out here in the ocean, well, kind of the same thing. There's no streets, there's no landmarks. You use latitude and longitude, and it will tell you your exact location. So, the advantage of using latitude and longitude primarily above anything else, here's why we use it, is because it is very, very precise. It tells you exactly where you are. There's no ambiguity. There's only one set of numbers with that particular location. Now, these maps are going to be used for more than just where we are. They're also going to tell us how far are you from one point to another. And you can see here that on Google Maps, you can actually do, hey, this is 696 feet from that point in engineering to over here in the fitness center in a straight line. Well, how does Google Maps take those points and know the distance between them? Well, they use the distance formula. And before you freak out and say, oh my goodness, this is math, I've never seen this before, this looks complicated, it's not really. If you haven't had this before, this is a mathematical formula that can calculate the distance between any 2 points A and B. And you use the Cartesian coordinates. You use the X and the Y, and the X and the Y of this one, and you use this kind of funky looking formula here, and it'll tell you the distance between those 2 points. Excuse me. But let's talk about on a map. A map is just a series of points, and every place on the planet has a point. So we should be able to use this distance formula to calculate the distance between any 2 points as long as we know their coordinates. But here's where this gets a little bit challenging. This point here, well, let's talk about what the latitude and longitude is. It is 60 north, and it is 90 east. Is where that actual point is. So I got some numbers. I mean, we plug some numbers into this formula. And we look at this one over here. We are at 60 south, and we're now at 120 west. So it seems easy. We just take these numbers and we call one of them an X and a Y. We'll go, X and a Y here. We call this one an X and a Y, just like we do in math. And we'll take those X's and Y's and plug them into this formula and get the distance between those 2 points. However, there's a problem with doing the math here. This was a 60 north, and this was a 60 south. The number is 60 in both cases. Well, our math, we can't put an N and an S in here and do the math with that. You should be familiar enough with algebra to know that this over here would be a negative 60 because it's going down from that equator or down from that x-axis, and you would call this a negative 120 because you're going in that negative direction from your y-axis. Well, that's actually also done with latitude and longitude. We will use positives and negatives as well as the numbers north, south, east, and west. And the reason for this is very early computers that were being used to calculate these distances couldn't do math with something that was like, we pick a point here, 60 south. An early computer had no idea to do math with the S. What did the S mean? Well, early computers could do math with a negative 60. So with latitude and longitude, you're also going to see positives and negatives. You might see this written as negative 60, which means it is going down from the equator or south from the equator. So you're going to see this written two different ways. This is 25 south. Well, south is south below the equator, so we could also call that negative 25. 115 west is going this direction from the prime meridian, which we associate with a negative direction in algebra, so we'd call that a negative 115. You can write latitude and longitude either way. Both are acceptable. But here's how we don't write it. We don't ever do this. Because this is like saying the same thing twice. A negative means, oh, it's south. So I don't have to say south. So you can say south or you can say the negative. You can say negative or you can say west. You don't say both. And we're going to practice writing them both ways because you're going to see them both ways depending upon where you're using it. So how does our phone know exactly where our location is? How does it know how far north we are from the equator, how far west we are from the prime meridian? This is where GPS comes into play. GPS stands for Global Positioning Satellite. And the origin of GPS goes back to the Cold War. You're familiar with this story that Sputnik was the first satellite that the Russians launched, and that was in October 1957. And as it was buzzing around the Earth, it was sending radio signals back. Well, and people were terrified of Sputnik because they were like, does this thing have a bomb on it? Is it spying on us? So scientists were very interested in knowing where that satellite was. Well, they very quickly figured out that by recording the radio signals, they could tell where Sputnik was up there in the atmosphere. Well, then the opposite also held true. They started figuring out, hey, wait a minute, if we can put a satellite up there and we can tell where the satellite is, the satellite can tell where we are, working in the opposite direction. And that led to the development of very early GPS ideas as early as the 1960s. Right now we have about 31 GPS satellites, and they can all pinpoint any location on the Earth, and it's through the use of electromagnetic waves. Now, who came up with this? First and foremost, it was the military. This was a military operation. Specifically in the 1960s, we wanted to know where our submarines were because they don't have roads and there's no landmarks. It was very difficult to tell where submarines were located. So they were coming up with a GPS system to figure out the position of submarines. It was first used in about 1973. By that time, we got 24 satellites up there. The military can start having an idea of where things are, not just submarines, but any target, any of your people, any of the enemy's people. And you can see in 1973, it was a pretty big, clunky computer. By 1978, you can see GPS has gone to be kind of a handheld thing, or at least a backpack thing. And by the first Gulf War in '91, it was literally a handheld device. Now keep in mind that this was the military. It was top secret stuff. Only the military had access to these satellites because they wanted to keep that information or that technology classified so the enemy couldn't figure it out and maybe get an advantage over us. So what happened? Well, in 1983, there was a problem. We had an airplane that was flying from Anchorage, Alaska, and it was supposed to go to Japan over here. And navigation technology wasn't so great, and it got off of its flight path and went over Russian territory, Soviet territory, and the Russians shot the plane down. Well, at that point, President Reagan and the rest of the government said, oh, wait, we got this system, we can tell, a plane can tell where they are if we let them have access to these satellites. And it was this tragedy where everybody on board was killed that led to the idea that GPS should be made available to civilians. And about the middle of the 1990s, it was then available to everyone. You started having GPS in your cars. Now we're going to do some sample problems here. This is going to be part of the summary document we're going to do. And let's do one or two together. We're going to look at point A here. And the first thing you got to say to yourself is this point north or south? Well, we see A is going this direction from the equator, so that is north. Well, how far north is it? Well, we come over here to the line of latitude, and we see it's on that line that is 30 degrees north from the equator. So we'd say it's 30 north. Now, is it east or is it west? Well, A is going this direction, so that is the east direction. Now, how far east or west? How far that? Well, it's not on this line. Oh, wait, it is on that line. Wait, that line doesn't have a number. If this line is 0 and this line is 30, the number in between must be 15. So the GPS coordinates for A is 30 north, 15 east. The longitude lines typically don't have numbers written on each one of them because the numbers get too hard to read. They get too smushed together. So you just have to look and see, oh, if that one's 30 and this one's 0, the one halfway in between would be 15. That would be 45 because it's 15 more than what 30 is. That would be 75. So what are we going to do now? That's the end of the presentation. The lecture's complete. You're going to come see me for a summary sheet. Now, I don't expect you to fill in every single blank or get everything right from memory. What you have to do is show me that you learned something and you learned enough to prove that, hey, I was paying attention. I learned something. I'd like credit for what I learned. And then that's when I will put a done stamp on your paper. If you can't show me that you learned enough from this presentation, I'm going to make you go back and rewatch it before you get your done stamp.